Thanks, Will. So for the first part of the demo today, we'll be using Fivetran to extract and load our data. Fivetran is a fully managed data pipeline as a service. We have over 170 pre-built connectors that are designed to very efficiently and very reliably bring data from sources to a destination warehouse. In this part of the demo, I'll be reviewing the destination setup, which is just a connection to Redshift, and then I'll also be loading sample Google Ads data using Fivetran's Google Sheets connectors. So this is the destination setup screen, and I've already entered the credentials for connecting to the Redshift warehouse. You'll notice on the right that the Fivetran documentation is embedded into each screen of our application. That's designed just to make it very simple to use so that you're not bouncing around from docs back to the application. There's not much to setting up a destination besides simply just entering the credentials and then testing that connection and ensuring that the connection works successfully. If there were any sort of error or failure, Fivetran would return that error message on the connection tests, and then you would be able to diagnose what the issue was and fix it. All right, so that's great, and now we can move on to setting up the connectors. So this is going to serve as our data source today. It is 3 sample Google Ads reports loaded into a Google Sheet. There are 3 sheets in this document, and the names of these sheets are going to be important for the connector setup itself. In Fivetran, when you go to create a connector, you'll get this list of some of our more popular connectors at the top. You'll notice Google Sheets is right at the top because it happens to be our most popular connector. But if I needed to search for a connector, I could also just start typing, and this would filter the list to more easily find the connector that I'm looking for. So I'm going to use Google Sheets today. And setup from here is pretty simple. So I need to give the destination schema a name. This schema name is permanent and needs to be unique within this destination. So I'll go ahead and use Google Sheets so I can keep all of my data from Google Sheets in the same schema. And then I need to create a name for the table within that schema at the destination. I'm going to use this naming convention that comes from my source data so that it's very easy to tell what data has landed where. So I'll start with final URL performance. From here, I could give specific access to this Google Sheets to this service account that Fivetran can use to connect to the Google Sheet. But since my Google Sheet is public, open to public view, then this authentication doesn't actually matter. Then I just need to provide the URL for my Google Sheets, which I'll plug in here. And when I click Find Sheets, Fivetran is going to hit that URL, connect to the Google Sheets, and then I'm presented with this named range dropdown. And the named range dropdown corresponds directly to named ranges that I've already created in the Google Sheet that correspond to each of my reports. So I'll pick this final URL performance since that is the table that we're creating, and hit save and test. Now Fivetran is going to make sure that it can actually find that specific sheet and find the named range within that sheet. Once that connection is done, I'll be able to then finish setting up exactly what I want to bring over and set up a schedule or a frequency for running incremental syncs on this data. So I'll hit View Connector, If I were setting up, say, a database connector or one of our SaaS application connectors, the schema tab here would have all of the tables and fields that are available as part of that source. And then I could very easily select or deselect specific tables or fields that I didn't want to include in the extract and load. But for Google Sheets, all I need to do is set up the sync frequency. So this will be the frequency at which Fivetran will continue to incrementally sync data over time. In this case, I'm going to go ahead and choose 3 hours. You can select anything from every 5 minutes, which is pretty frequent and not really recommended except in very specific use cases that need that level of frequency of a refresh of data, to all the way up to every 24 hours. And that's it. If I go back to status, I can now start the initial sync, and you'll notice there's some progress indicators that have now started, indicating that I am syncing data, and it is the historical sync or the first initial sync of this connector. Once the sync is complete, I'll also be able to drill into some history of syncs on this connector, which I'll show in a few minutes once this sync has completed. But for now, let's finish setting up the other connectors in a similar fashion. So I'll just go to Add Connector again and Google Sheets. And I want to use the same destination schema name so that all of my Google Sheets data tables land in the same schema in the destination. For this connector, I'm going to use the Click Performance sheet. So I will use Click Performance as the table name as well. And then again, I just need to put in the URL to the Google Sheets and click Find Sheets. At this point, Fivetran will again go and detect the named ranges, and I just need to select the named range associated to the data that I want to bring, and that in this case is Click Performance. And I'll hit Save and Test. Fivetran will go through the same steps of connecting to the sheet, validating that that named range exists and that it can find the data that lives there. And from there, all I need to do to finish this configuration is select the frequency at which Fivetran will run the incremental updates. Great, so those connection tests passed. I will go and select that frequency on the Setup tab, and I'll pick 3 hours, and then I'll start that initial sync. And then from here, I just need to set up the third connector. So we'll follow the same steps as the previous two. I'll click Add Connector, Google Sheets. This time, I want to use the Criteria Performance sheet. So I'm also going to use that for the name of my destination table so that I know where to find the data. And then I'll paste in the sheet URL and click Find Sheet. Fivetran will come back with a list of named ranges, and for this table, I'm going to use the Criteria Performance range. Click Save and Test. It's going to go through the same steps of detecting the named ranges within the sheet and ensuring that Fivetran can access that data. And then I'll just set up the sync frequency and start the initial sync the same as before. Now that this connector has completed its sync, I can also see some of the sync history. So I'm going to switch this view to just 1 hour so that the bars are a little larger to see since the sync ran so quickly. The green bar indicates the entire time of the sync, in this case just 39 seconds, but then each step is also broken out. So the extract time, the process time, the load time, and you also get a count of the size of the data volume that was loaded. I can also look at that in Fivetran's logs, which contain JSON entries for each of the events that occurred during the load. And from here, I'll hand it over to VJ to talk through Trifacta.
Thank you, TJ. Now that the raw data has been loaded into Redshift, we are ready to transform it. We will do this in a 5-step process. First, we apply some data quality rules against the incoming data. Then we'll build a time series and make sure that there are no gaps in our data. We'll then join and summarize our data, then calculate some derived metrics off of it, and finally publish the result to Redshift, after which we will run a quick site dashboard. We are now in the Trifacta user interface in the flow view, which consists of data sets, which are these icons you see on the left. And attached to those data sets are recipes, which contain the transformation logic. I'm going to select the recipe for final URL summary and click on Edit Recipe. And this will bring up the data set in a familiar spreadsheet-like view where I can start browsing my data. Now, I want to apply some data quality rules against this data set. Specifically, I want to make sure that the combinations of certain columns are unique. I can do that by switching to the columns view, and I'm going to select a few columns, particularly the date, the campaign name, and the ad group name. And notice that as soon as I select something, I start getting these suggestions. I'm going to pick this suggestion to merge these columns and actually create a combination column out of it. So I'm going to call my new column combination, and we'll be making sure that this combination is unique. So I'm going to add that, and then going back to my grid view and choosing data quality rules, I'm going to add a rule which applies a unique constraint on the combination. Now, notice that when I do that, I get this data quality bar, which gives me a score of what proportion of records are passing or failing that test. If I click on the red portion, which is the failing rows, it immediately highlights those rows where there are duplicates in the combinations. Now, this is obviously a problem which we want to address. So in order to address that, I can add a recipe step. In this case, the way to resolve these duplicates is by summarizing, which I will do through a pivot table. So I'm going to click on the pivot transform. And here, I'm going to summarize this information by the combination and also include the individual columns, which is the date, the campaign name, and the ad group name. And in the values, I'm going to summarize the sum of the cost, the impressions, and the clicks. Now, as I'm building this pivot table, notice that I can see a preview of what the output will look like. So this matches what I want, so I can go ahead and click on add to add this to my recipe. Now, as soon as I have done this, if I switch back to my data quality rules, notice that my unique constraint is now being fulfilled because all of my duplicates are gone because of the summarization I just performed. So now that we have taken care of the duplicate record issue, I'm now going to go back to the flow view and we'll work next on our time series. Now, one of the things we want to make sure is that we have a full 3 quarters worth of data with no gaps in between. In order to do this, we will create a time series covering every day within the 3 quarter period. Now, notice that we are starting with a blank data set, but I can quickly add a macro that will build the time series for us. So I can simply invoke this time series macro. And here, this lets me specify the start date and the end date. So I'm going to start with January 1st and end with November, or rather September 30th, and create a new date column. And that will simply create a time series for me with every single date from Jan 1st to November 30th. Now, behind the scenes, this is actually doing quite a lot. If you look at the details of this macro, it's applying a bunch of transformations in order to build this time series. But luckily, I don't have to worry about those details. Those are all abstracted away from me. I'm now going to delete this extra column that I don't need. Now I can simply click the column heading and notice that I get some suggestions, one of which is to delete this column. I'm going to add that to my recipe. And now that column's gone. I'm now going to switch back to the flow view and now work on the click details recipe. And what we'll be doing here is we'll be doing a lookup to combine the time series information with the click performance data. So we can easily do that by simply using the column menu, choosing lookup, and from this list, we can pick the click performance data set, and we will use the date as the lookup key. And by clicking on executing lookup, it'll go ahead and fetch those values from the other data set. And now I have my time series with the click performance data right next to it. We'll now apply some additional data quality rules to identify gaps, if any, in our time series data. I'm going to go back to data quality rules and add a rule to make sure that the not missing constraint is applied to the campaign name. Now, notice that this particular data quality rule has a few failing rows. If I click on that, it appears that campaign name is missing. And in fact, all these columns are missing for certain dates in my time series. Now, this is not a problem we'll be fixing at the moment, but keep note of this, and this will be outputted in the data quality profile report at the end of the process. Next, I'll go back to the flow view, and this time I'll work on the campaign summary recipe. And what we'll be doing is we'll be summarizing campaign metrics to identify the most effective advertising campaigns. For this, what we will do is we will use a pivot table, which is found on the toolbar, and we'll be summarizing our various metrics. So we'll be grouping things by campaign name and calculating the sum of costs, the sum of impressions, and the sum of my clicks. Notice that as I am building this pivot table, Trifacta provides a live preview of what the end result is going to look like. So I can confirm that that's what I want and click on add to add it to my recipe. We now have some basic metrics summarized at the campaign level. We can calculate some derived metrics on top of these. So I'm going to now add a new step, and this is going to be a formula-driven step where I calculate cost per click. And the formula for that is simply the sum of the cost divided by the sum of the clicks. And similarly, I'm going to add another derived metric, also formula driven. And this is going to be impressions per click. And just like the other one, the formula here is the sum of impressions divided by the sum of the clicks. And add that to my recipe. We now have a few metrics we can report on at the campaign level. We can further enhance our campaign metrics by bringing in sales data from our ERP systems. I'm going to perform a lookup, and in this case, I'm going to bring in data from the sales summary table. and look it up by campaign name. Once I have the sales information, I can use that to calculate sales per marketing dollar, which is a great measure of advertising effectiveness. And the formula for that is sales divided by some cost. Looking at these results, it appears like holiday promotions are giving us the best sales per marketing dollar. Now, the final stage of our data transformation process is to publish some of these results into Redshift. And we're going to do that by creating an output to run. And we can edit the destinations for our data output. In this case, I'm going to switch away from the default, which is an S3 CSV file, and instead add a Redshift destination. Now this will prompt us to choose the schema name, which I'm going to choose as Google Ads Demo. And also the campaign summary is going to be the destination table name. You can choose to either append, truncate, or drop the table for every run. In this case, I'm going to basically replace the table, which is the same as drop. And I'm now going to run a Photon job to actually run this transformation and persist the result into Redshift. The jobs have now finished executing, and I can access the job details by clicking on them. You can see the overview of the job as well as a detailed profile of the records that were outputted, as well as any data quality rules and the result of the application of those rules. Now that the data has been stored into Redshift, I can go ahead into QuickSight and access my dashboard. This dashboard actually summarizes the results of my campaign. And QuickSight actually gives you an interactive view by which you can drill down on specific things. So for example, I can drill down on organic, and this will immediately refresh all the panels within my dashboard and filter it based on my selection. So you can see I have a few tree maps as well as scatter plots and tables in my visualization. Also notice that QuickSight is able to provide machine learning driven narratives such as the week over week trends as well as the trend lines which are forecasted into the future.